welcome everyone. Welcome to our webinar this afternoon on church heating to replace or not replace, a very important question for many churches around the country. If you've been to one of my webinars before, you know I always start with the future attractions. So today's webinar is part one of a two-part series where the first is to replace or not to replace, and then the second is choosing the right heating system. So if you've decided to replace, how to go about thinking about that question. And Susan's running that. I've got two more dates coming up on the 4th of May and the 18th of May. And a repeat of today's webinar on the 25th of May. So if you get to the end of today and think, oh, I wish my colleagues had been there, there's another chance for them to come along. And then of course, there'll be the video on the website as well. We've got the final date of our church lighting for energy efficiency webinar on the 11th of May. And then coming up in June, when it is Churches Count on Nature, in the second week of June, we've got a special themed programme of land and nature webinars, 12 different topics over the week, so there's something for everyone. We've then got a new topic that's just recently gone onto our website, all about heat pumps, because we know that's such an important issue in terms of potential for low carbon heating. So you might want to go onto our website and book for the heat pumps webinar. We've got some new EcoTeric topics on there as well, one on getting started, one on getting to bronze, and one on how EcoTeric links up with net zero. And then I imagine this one will be of interest to a lot of people. By popular demand, I have found somebody to deliver a special two-part webinar series on environmental fundraising, where the first is on what opportunities there are for funding out there, and the second is on how to approach your fundraising for environmental projects. They're not till September, but I popped them up on here because I know a lot of people want to know about fundraising. So I will put the links to these different webinar programs in the chat when I finish the introductions. We'll be using the Q&A rather than the chat for questions. So if you move your mouse around, you'll find the Q&A down the bottom. That's where to pop your question. And you can also click the thumbs up next to other people's questions. And at the end, the time that Susan has left will focus on the questions with the most votes. I'm recording the talk, so it will end up on our website. And also I will send you the slides after we finish, and any links from the chat and a link through to our feedback form. Right, on to the main event. So Susan is very experienced. You are in safe hands here today in terms of discussing church heating with someone who really knows church heating. So CIBSE, 40 years advising on energy efficiency and carbon efficient solutions, and a very experienced heating advisor at Worcester Diocese. I think you've seen every type of church heating that there is. So if I stop sharing my screen now, and with no further ado, hand over to Susan, you can share your slides and take us away.
Okay, lovely. Well, hopefully that's the right screen. Just
looks perfect to me.
So welcome to everybody. It's great you've been able to join us. And as Catherine said, this is the first of two talks. One is focused on what sort of heating you might want to replace with, but this one is about, well, do we really need to replace our heating? And with so many things, it's not an easy answer. So what I'm going to do today is to go through the thought process of what you might want to think about, what you might want to consider, what state your current heating's in, and hopefully come out of that with, if nothing else, a thought route map to plan for now and the future. So we shall go through that, and whilst we're doing that, we need, of course, to be rooted into thinking about how we get to net zero carbon, because that's what it's all about, really. But at the same time, we've got to think about our mission and everything else. So that's what today's about, is to give you some tools in your toolbox to think about heating and how we might consider it going forward into the future. So, if my system will work, there we go. So it's a people thing. So before we start, we've really got to understand and be focused on people. Our church is for and about people, and without people, we don't have a church, we have an empty building. So that has got to be the priority in anything we think about. But of course, if we don't address climate change, we don't look after creation, we don't have a planet either. So we've got to try and walk the rope between the two priorities. And what heating means to people. It's a fundamental part of our mission, really, is to make people comfortable. Well, comfort means a few different things, but if people aren't comfortable, if they're not happy, if they're not relaxed in our church environment, then we're not necessarily achieving the mission we set out to. So the first question I always ask when I go and meet a church for the first time, or maybe even the second or third time, but when I go to a church or speak to anybody about the heating, the first question is, are we warm? And whilst sometimes church members, regular attenders, can say, well, you know, I'm happy enough, I'll put my thick coat on and my thermals and all of that. We've also got to think whether people who are less used to that environment, are they warm enough too? Is it welcoming? We need to think about what we want to achieve as a faith body. What is it we want? Do we want to grow the church? Do we want to encourage broader usage? Do we want to expand our mission, or perhaps we're thinking about doing different things in the space? We also need to think about what the building needs to keep it, to preserve it. We'll come on to that a bit more later on. So clear goals come from clear needs, and most of you will be familiar, if you've ever done any development or changing anything in church, on a statement of needs. And very often people think, well, why do we want that? Well, because clear goals come from clear needs. If we know what we need, then it's a good basis to make decisions. So we might know what we need now, but we really need to think about what we need in the future as well. So are we planning any changes to the building? So very often I get called into a church at a point of reordering, maybe. So when a church is thinking about putting kitchens and toilets in, possibly taking pews out, possibly even extending. And that's a key pivotal point to think about the heating system. And it should always be part of the thought process with any reordering plan, because it might change, or the need for better or more extensive heating might need to be incorporated in a funding application, for example. The next question, so that will be question number 2, are you warm? Number 1 is, are you warm? Number 2 is, are you planning any changes? And number 3 question is, how often do we use the building, and is that going to change? So do we currently use it once or twice a week? Sunday services, maybe a midweek meeting, weddings, funerals, christenings, and so on. Is that going to change in the future? Is that going to, and how secure is that possible change? Is it a maybe, or is it a more definite change? When you think about who will use the building in the future, it might be a broader usage. So have we got community use? Are we thinking about running toddler groups or luncheon clubs, citizens advice bureaus, post offices, exercise classes? All of those things are now becoming quite common in church settings. What implications does that have for our heating system? So we might be needing to, for example, have a warmer temperature for use with elderly and young children. We may have needs for safe temperatures. What will people expect from the environment? Are they going to book and use the space if it doesn't meet the health and safety requirements? I was at a church recently where the centre is being used as a vaccination clinic, which is probably a temporary usage, but nonetheless that changes what you might need. And of course, we have to think about, in these days of COVID, that our ventilation might need to be improved, or we may need to balance the needs of energy conservation and our heating whilst we keep some fresh air moving through the space to reduce any infection risks. So when we think about our needs, we do need to think about risks as well. So what are the risks and what are the needs? And not overplan, of course, but just be reasonable about that. Another example might be where we're thinking about using the space for sports, because if balls are flying around, then obviously certain types of heating and in lighting indeed can be quite vulnerable. So how do we use the building at the moment? I've already mentioned how often is the building used, but then we go on to say, well, there's another question. This is my routine question list. So anybody that has had me there will have been asked these questions. How many people use it? And that can matter as well, because obviously if the usage is semi-full, that's a different environment for heating to services where there may be five people that meet together. Because you might be able to, for example, to heat those 5 to 10 people more efficiently and effectively, if that's the congregation you've got, in a different space. It's an alternative to using the main space. Is it more efficient when you've got smaller gatherings to congregate in smaller spaces? And can that space be made suitable for its usage for worship or prayer or other community uses? So how can our spaces be used is another question that most churches do need to think about and to address. And again, when we're thinking about reordering, is there a small chapel or a small enclosed space that could be enhanced as part of our reordering for that purpose and heated for smaller gatherings? We also need to think as well, when we do that, about how long it takes to heat the church up as well, whether it's a long preheat just for a short service, because that again can determine some of our choices. Then we have to think about what the building needs. Now, we are custodians of a huge amount of heritage, of course, in the Church of England. So first of all, are the listed or precious interiors or artifacts. So where we've got, for example, a grade 1 interior, there's often a need for consistent, steady heating. It's called conservation grade heating, and the point of it is to avoid rapid changes in temperature. We need to keep a steady background heat. Most buildings are better not being heated up and cooled down on a regular basis. That's a luxury in both cost terms and carbon terms. So we need to be very critical about any requirement to keep our heating on all the time, because that will be costly. If we get a lot of fluctuation, what happens is that moisture moves in and out of the building, and the photographs there show some of the effects of a long period of moisture. The salts in stone come to the surface, the stone can flake. When we've got things like paintings or woodwork, we can get cracking in the woodwork and laminating on the painting. So it's quite an important topic. So if our building is showing signs of deterioration, that is a point at which we might need to be thinking about how it's heated and how it should be heated. What do we need to preserve it? It's quite a specialist subject, and it's not necessarily intuitive. In some cases, where we've got very important churches, we don't heat at all, which is not great for the people, but it's very good for the building. In others, we monitor closely the temperature and the humidity and make sure that that isn't fluctuating unduly. So it's quite an important topic, but the vast majority of buildings are quite tolerant and can be heated up and cooled down as required. So at the end of that little exercise, you should know a number of things. You should know where you want to heat, how much you want to heat, what you want to achieve in terms of temperature, who's going to be using it, and what's right for the building. So now it's time to look at what we have. What have we got there? Well, there's a couple of photographs from my album there. One is some tanks on a wall. These tanks are there to provide water to the system. Heating systems do lose water every now and again. So that's part of the system. If you haven't got any tanks and it's an older system, that might be a point at which to worry, but I'll talk about that a bit more later on. We might have some older uninsulated pipework there. Where's the boiler? Number one, where is the boiler? A lot of boilers were put in undercrofts. They would have replaced an older coal or coke boiler, which would have had to go down there really, because there wouldn't have been anywhere else much to put it. Sometimes the chimneys or flues are less than ideal and certainly not to modern standards. If a boiler is in a damp area or even worse, an area that gets flooded, that's really a good time to start thinking about a new location. Older boilers are quite tolerant of damp. They've lived there for a while and they haven't really come to any great harm. But modern boilers these days, efficient ones, have got circuit boards and microprocessors built into them that really don't like damp at all. And in my diocese, we've had a number of boilers that haven't lived anything like as long as they should have done really, in undercroft locations. And for that reason, we quite often try and shift them out of there. I mean, the days of getting 20 to 30 years out of a boiler, I'm afraid, are gone. The older boilers would have done that, but new ones are far less so. What else might we have? Well, where are the tanks that feed the system? There's a nice rusty old tank there with no lid on it. Might have a pigeon or two lurking in there. It might not have mains water. That's a big question. So church I've been to, I couldn't find the water supply. So I said, well, where's the water? So we don't have any. So, well, how would you top your water system up? Well, we fill the tank with a bucket every now and again. Well, and I'm sure they do, but if ever it got forgotten, had a leak and something went wrong, then what happens is a boiler could be firing with not enough water in the system. And at very worst, that creates steam and potentially an explosion. So that's not so good. The system needs a vent. Again, I've seen quite a few where a system would not have vented steam effectively in the event of boiler firing too much or not enough water in the system, and the steam would have not escaped in a safe way. I mean, I haven't had a system that's failed like that yet, but you know, we always have that possibility. What do the electrics look like? Have we had a recent electrical inspection on our quinquennial? And again, I find that boiler electrics sometimes get forgotten about. The cabling and distribution of main church is okay, but once you go down into the boiler house, there's stuff there that looks like it predates the Second World War, and it possibly not in very good condition. So again, quite often a boiler upgrade means an electrical upgrade as well. And certainly when you're looking at low carbon sources that may be electrically derived, then an electric upgrade is very often needed as well. And oil tanks, there's an illustration there of an older type of tank. Now, there are more than there should be occurrences of pollution to ground and water courses from oil tanks that leak. They should be in a place where any leakage is contained either within the tank or within an enclosure. And therefore, it's really important to know what you've got in terms of an oil tank and whether it's currently legal or not. And that is important if we're responsible. And one more thing I'd always say, again, it's very, very common when an oil system is being replaced, they say, well, can we just leave the tank there? And I go, well, you shouldn't really, because it's not responsible. It's leaving a legacy for the future generations to have to deal with. You should empty, degas, and remove an oil tank when you're finished with it and when it's no longer required. So here's a few more clues to look at. How old is the system? The most common answer I get is, well, I think it was replaced about 15 years ago. And generally when you look in the boiler, it's 30 years because time passes, doesn't it? It really does. It flies when you're looking at systems. The service life of an average boiler is 15 to 20 years. Because of usage, lower usage, of course, churches tend to get a bit more out of it. But frankly, if your boiler is 20 years plus, then it is needing replacement. Does the system leak? So go around and see the telltale bits of rust round joints in the heating. Does it have to be topped up, or does somebody go around with an air vent every couple of weeks because it's always got air in? Now, air coming into a system or leakage means that there's fresh water going into it. That means it's corroding. That means that the pipework is getting worse and worse week on week. How much does it cost to run, and how much should it cost to run? That's a question obviously our churches don't ask. They say it's expensive. Well, what's expensive? Quite often when we replace a system and the comfort improves, it can actually cost more to run, but it supports the ministry and therefore is a worthwhile expense. Is the boiler easy to get to, or is there a rickety ladder or a heavy door or a staircase that's slippy? It should be capable. You should be able to get to it reasonably easily. How long does it take to warm up? So if our system is undersized or in poor condition or it's corroded, the warm-up time gets longer and longer and longer. We're talking boilers here really, but there are other types of systems. But basically, if it has to be turned on the day before to get anything light and warm, then we've got some problems, I think. Is the building damp overall? Is the heating just not keeping it warm enough to avoid damp? Or is it damp from another cause? Increasing the heating does not necessarily deal with damp. Damp can come from a lot of different sources, you know, guttering being the prime suspect, of course. So we should have some clues by the time we've finished this. We should be thinking, actually, we've got an old system that leaks, it takes 2 days to warm up, I can't get to the boiler, and we're not warm enough anyway, and then we start to build a picture. Of course, nothing is ever that straightforward, and it can be yes to some things and no to others. So our boiler, what did we find? Did we find a boiler that was 20 years old or more? Did we find our electric heating? Some of it's failed, the wiring's starting to break down. We've got advisory notes on our electrical inspection. What are our controls like? Modern controls are a great thing, of course, but older controls are probably basic time clock. How do we control the system? So if we've got somebody using our building, can we just flick a switch and put it on for 4 hours and it goes off automatically? Or is the overburdened church warden tasked with having to turn it on and off? Can we do something better than that? What's our flue chimney like? You can see some of the pictures here. We've got some things that are not looking so great. The big hot spot there, and can we smell gas in the space? Have we got that gassy sort of smell? We might not have good enough ventilation. Ventilation, as a rule of thumb, you should always have high and low ventilation into any chamber where a boiler that looks something like these two pictures, because they take air from the space and mix it with gas or oil and then put the products of combustion up the chimney. If you don't have the right amount of fresh air, then you can get inefficient combustion and quite dangerous combustion, because you might get carbon monoxide generated in the space. And if you've got any doubt at all, a relatively cheap carbon monoxide detector is always a good idea. What are our systems, safety systems like? So if we've got a gas or oil shut off in the event of fire or in the event of emergency, as we mentioned before, can we get steam out the system and fresh and cold water into it automatically in the event of a problem? Have we got obsolete systems? That's when I say obsolete, I mean old electric heaters, for example, that can't be upgraded. Sometimes we find gas plaque systems. These are gas burners where sort of radiant gas, where the products of combustion are into the space. They're not such a good idea, really. Have we got systems where we can't get spare parts anymore, or where parts are starting to get really difficult to get? As I mentioned before, is our water supply missing? Have we got noisy failed heaters like fan convector heaters of one sort or another? Are things past the end? And have we got any blockages and leaks? One of the common problems with deteriorating systems is they start to block up. So then we come on to this topic of changes to the building. Now, can the system be adapted? And I've got a little picture there of a very common single pipe system here. Now, single pipe system, there's a little diagram of it, was probably the most common way of heating a church, really from Victorian times onwards. There might be big pipes, there might be smaller pipes, but basically the water goes round by gravity, and the radiator nearest the boiler is hotter than the radiator furthest from the boiler. For that reason, the radiators can sometimes be smaller on one end and bigger on the other end. But if it's all in one space, it doesn't really matter because it evens out. Although clearly, if you want to sit somewhere, you want to sit near the radiator that's nearest the boiler. These systems are fine until you start to want to change them, and then they become really, really inflexible. Because it's very difficult to move pipework over doorways, under doorways. It's very difficult to adapt, particularly if you're putting enclosures such as a kitchen or toilet in there. So at that point, we might have to think about, well, it's difficult to adapt, so we may need to change it. If we've got two pipes, one underneath the other, where one pipe goes to the top of the radiator or one side of the radiator, the other pipe goes to the other, that's really adaptable. That's a two-pipe system, and that's quite easy to change. If we've got cast iron pipework, that again is very, very difficult to change because it's difficult to joint, and very often the joints fail, needing ugly and quite expensive repairs doing to them. So when we are looking at biggish changes, when typically these radiators, like the one I have illustrated there, can be fixed to the end of a pew. So when we're taking the pews out, then the radiator's got to go as well. The pipework sometimes runs in the pew platforms or along the pew platforms. We've been to see one recently where the pews are coming out, and the whole heating system really will have to be replaced. So, as I say, if we're taking our pews out, what we really have to think about there is pews are not the most comfortable things in the world, but if the heating runs in or around them, they do deliver heat to where people are. And as soon as we take them out, then we could have a large church, as I've shown illustrated there, with seats, where it's quite difficult to get heat to where people are in the centre of the church. So that's another point at which you might think, well, what are we going to do about that? I mean, we've got columns, we can put column radiators in. What we can't do very easily is get heat to seats. If we've got seats, as I've shown on the right-hand side of the slide there, where we've got seats, we can put pipes or electric heaters to deliver heat to where people are. And these can be quite effective and also quite efficient as well. But where we're taking them out, then obviously we've got to think of a different solution. I don't want to leave this talk without some pointers on heritage. You might not think of your heating system as being a historic artifact, but it can be. Obviously, there's some more important than others. There's a gurney stove there, which is quite a magnificent object, beloved of cathedrals, and most distinctly part of a listing. It would have originally been coke fire, but some of them have been converted. In any case, they're a historic object. So some heating and lighting too, actually, might be part of the listing. And for example, there may be remnants of old gas lighting, which would be quite important. So anything original to a listed church should be thought about and possibly preserved. And you can, of course, install a modern system over the top of it while keeping the older equipment in situ. It doesn't have to continue to be used, although they can be in some cases. If in doubt, it's something to talk to the DAC about, of course, and get some advice. But here's a few pictures of things that I would most distinctly not want to see taken out. So we have there, that one obviously has been taken out because it's in the middle of the field, but you can see the decorative ends to that. That's a Victorian early form of radiator. There's quite a nice decorative one there. There's some interesting purpose-made pipe work there. Some of the older cast iron radiators might not be that interesting, but where they've got decorative features are really quite nice. Some older stoves there. That's a Hayden stove at the bottom right-hand corner. They're very rare now and should probably be left in situ. CIBSE also have a heritage website where you can see more of this type of thing. Our Victorian systems are disappearing, and I'm not saying we should preserve them all, but I think we should preserve some, and some of the earlier and better examples too. And cast iron radiators are actually quite sought after. They produce an almighty amount of heat for very little wall space, which is more than you can say for most modern radiators. And where in churches, we're often short of our wall space, particularly if we've got pews. So we get a lot of heat out of them. They can be restored, they can be taken down, stripped, repaired, and put back, and they have a resale value as well. They warm up slowly, which some people say is inefficient, but they cool down slowly too. So if you're clever with your controls, that they can be a very useful to preserve. And they also can meet our objective of making sure our heating doesn't warm too fast or too fast, thereby doing damage to our interiors. So is our heating efficient? I get asked this an awful lot. Well, possibly not. An old boiler, right? So an old boiler, say one I illustrated earlier, or perhaps in the next slide I've got. So the right-hand boiler there, when it was brand new and working wonderfully, it would have been about 84% efficient. A modern boiler will be at least 94% efficient. So you've got 10% efficiency loss before you start, even if the boiler is working at peak efficiency, which it probably isn't. See the pipe work there that's all furred up? That's what I was talking about before in terms of getting corrosion and scale and build up. Now that pipe isn't going to put very much heat out at all, and the pump isn't going to be working properly either to get the heat through it because the resistance is too high. If it's leaky, it's poor efficiency. If it's a long time to get warm, then we're wasting a lot of energy trying to get the place warm and cold again. So if that's not efficient, here's a few more. We still have some antique boilers like the one on the left-hand side. I'm still seeing those. They're probably about 60% efficient. And we've got some with where the controls are probably hardly functioning as well. So we've looked at what makes heating inefficient. So what makes it efficient? Well, it's efficient when we deliver heat to where people are. So clearly, if we're heating our people, not the birds and the bats and the rafters, then that's obviously got to be quite good. If we're delivering heat, we're avoiding big swings in temperature. that will generally use less energy. If we reduce the space we need to heat, that will save a lot of energy. Reducing the time the system is on, having an efficient heat source, and matching the demand as closely as we can to the supply through good controls, that will be an efficient system. So where can we get help? Well, and what tools do we have? There's EcoTeric, there's Church of England guidance, there's Catherine's very excellent heating papers. And measuring and reporting what we have is really important. So if every church I went to had their energy bills, and so we've used the church for 1,000 hours this year, and this is our bill, then we can very readily convert that to a nice little metric. Well, it's costing you X amount per hour to heat. So it's always worth doing that, and then seeing, well, actually, is it costing us £20 an hour to heat, £50 an hour to heat, £80 an hour to heat? And what does that mean in terms of what temperature we're achieving? So if you know all of that, then you've got a real good measure of how efficient your system is. So I will talk a lot more on the next seminar on carbon and heating, but it's worth having a little bit of an explanation here, so that when we're talking, because we've talked a lot about heating, not a lot about carbon at the moment. So principles, this basic principle of carbon is we should use as little as possible. That goes for carbon in life, doesn't it? The lighter our footprint, the lower our carbon. It doesn't matter what we're doing, whether we're traveling, whether we're purchasing, whether we're looking at waste, whether we're looking at heating, lighting. We should use as little as we can. What we have to use should equal the demand as closely as possible. So we shouldn't be overheating, we shouldn't be heating for longer than we need to. And then lastly, after we've done the first two, and it is after we've done the first two, and that becomes particularly important when you're looking at low and zero carbon heating sources, we should we should use the lowest possible carbon source. So it is in that order: demand, supply, and carbon source. So what does that mean in practice? Well, one thing we can do if we're not too warm is insulate. And a great time to insulate is when we're doing roofing, because insulation can be added at that point. We can insulate, there's a picture there, top right-hand corner, might not be obvious what it is, but this is an underfloor duct, which is very common. The Victorians used it either for warm air from a coke boiler or for pipe work. They lose a lot of heat. You can do quite a ready DIY job by putting some insulation in, keeping the duct open, but insulating the walls of it. And these cast iron grills that you see in so many churches, they were there for a reason. And they were there when the church was packed out. Victorian churches were. They had wall-to-wall people. Might not be, it smelled too nice. There'd also been gas lighting, in the space. And they needed ventilation for health and hygiene, just as we do now, actually. So a lot of drafts come from these grills, which you might not currently need. Always talk to your inspecting architect and make sure that the building can still breathe. But very often the drafts can be reduced. They often have a vent at high level as well. And use space wisely. So the less space you use, as we've talked about before. So in terms of low carbon heating sources, clearly we measure carbon in kilograms of carbon dioxide equivalent. And clearly our true renewables, our photovoltaic panels, wind and solar, thermal, have no emissions. Obviously they have some emissions when you make them, but after that they don't, or very small. After that comes biomass. I'm showing the figures for pellet, but also there's other types of biomass as well. We'll talk again more about biomass on the next one. because that has it, although it is a low carbon source, it has got air quality issues. Then we get to heat pumps, which take electricity in and put heat out at least 2.5 to up to 5 or 6 times the amount of electricity in. So the carbon there is reduced by the fact that they put out more energy than they take in. Then we have our traditional sources, gas, LPG or Cala gas, you might know it as, propane-butane, isobutane, or all the gases that are derived from the oil industry. Then we have electricity, which is an interesting one. I've shown it there as last year's. It's coming down all the time. So as the grid gets more and more renewables into it, that electricity is going to come further down. And it's expected that it will overtake gas in terms of carbon in probably the next few years, but certainly by 2030. And then the last one is oil. I've put there a typical oil. There are others, but they don't vary too much. I haven't shown coal on there, but that's another stage up. So what to choose? Well, again, we've got another seminar on that one, so I can't go into it too much. But as a principle, the lowest carbon source for the life of the system. And we'll be asking on the next one that set of questions. I'm not going to linger on them too long now, but what fuel do we have now? What could we have? Do we have single or three-phase electricity? That's really important when you're talking heat pumps. What's available? How can you get fuel into the building or the vicinity of the building? Are you going to replace the heating system? What temperatures can it work at? What space do we have to put things, put plant and equipment? And what can we afford or get funding for? And the most important of all of that is planning. So whatever you've got at the moment, unless it's absolutely brand spanking new, you still need to plan. So the choices are going to be the subject of the next webinar, but both this webinar and the next one will say the same thing. Plan, 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 and plan. Budget, 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 so that you've got the widest possible choice when you come to need to do it. One of the harder parts of being a DAC advisor is when you get the call when the boiler's failed, particularly where advisory work has been done over the years, and then we've led to failings that at the point of failure with no heating, the church is in a difficult position unless they've got funding to replace the system. And it's a point, you know, which I never want to be called, really. It's very difficult because then you're making choices that might not be optimal. And I'm sometimes asked, well, what about embodied carbon? Surely if we put a new system in, then it's going to take more carbon to make it than it is saving in the emissions. Well, so embodied carbon is the carbon it takes to make and build things. So is it better to use an old system or replace it? Well, generally it isn't better to use an old system if it's not efficient, because the operational carbon will exceed the embodied carbon quite quickly. As we get to zero carbon, things start to change a bit, but with most heating systems, we're nowhere near zero carbon right now. How could we be zero carbon? Well, one of the ways, of course, is to, if you've got an electrical system, is go onto a true green tariff, but again, more of that later. Another question, regular question, and there's a photo of a very old boiler there. Should I repair or replace it? Well, I'm not preaching here that we replace all our heating systems. I'm really not. Because sometimes a church could afford a better, lower carbon system given time, and sometimes it is better to repair and carry on whilst we are actively fundraising and planning for a better system. If it's very, very, very low usage, which again is not uncommon, and we have to think also about the future of some of our buildings, possibly it's not a wise investment until our usage is better or our future is known. Are we throwing good money after bad? Have we repaired and repaired and repaired, spent a lot of money, and then having to spend more? That then maybe tips into the replacement scenario. Quite often, I go to a church and they say, oh, it's been condemned. And you think, okay, I can't get the part. And sometimes another company that you go to will go, well, actually, we can get the parts. And sometimes that second opinion is worth having. So to sum up, to replace or not to replace our heating, does it work reliably? Does it keep us warm? Does it heat up quickly enough? Can it be controlled to heat just the spaces we need? If it can't, well, maybe it's time to replace. Can it be adaptable to potential changes? Is it likely to fail? Is it efficient? Is it low carbon? Yes to most of the above. Keep it, but always plan for the future. Now, start planning and budgeting now, and the next seminar will help you. And I'm just going to take a couple of minutes right at the end just to sum up and a couple of case studies. So if you've got more questions than answers, get some advice and support. I'm one of a number of DAC advisors that give their time as best we can on a voluntary basis. But if that's not available, there are CIBSE engineers out there, building services engineers that can help you too. Record what you have and what you need, and set a budget for now and the future, and have a plan to reduce carbon. So here's a church, very, very beautiful church, grade 1, scheduled ancient monument in close proximity. And I was called in to report on it. It was underheated. The boiler was in the classic heavy door, very difficult to get to. It was very inefficient. The system was difficult to modify. A very large church with a limited electrical supply. So our choices were limited there. The system did need replacing. Gas as a medium-term option was the only option available. And investigating some sort of solar panel if possible. Here's another one. Another big church with a balcony. It used to have a balcony, very, very high indeed. It was underheated, but they were considering full replacement. But actually in that case, putting some new boilers and some extra heating in was more than good enough. And the church is now comfortable, but with a much lower expenditure than they'd envisaged, and no more and lower carbon too. But although they will have to think about a longer term future. And lastly, a little highly insulated church hall extension with unconsecrated ground available, and that's ticking away lovely with some underfloor heating and a ground source heat pump. Very, very different things, but and very different outcomes. Well, I hope that's been informative, and I, very much welcome some questions. So I shall hand back to Catherine at this point, and off we go.
Thank you so much, Susan. And we have got quite a few questions. If you're listening in, you haven't found them yet, click on the Q&A thing down the bottom, and you can see all the questions that are in so far. You can vote for the ones that you're most interested in, or type your own in. And we'll just start at the top and see how many we can fit in before 5 o'clock. So the top of the list at the moment, just flicked. At the top of the list at the moment is about grants. So I will find the 2 links which I always send people to, one of which is our grants directory and one of which is Community Energy England. There is no quick and easy answer. Those are the places I would look first. Susan, any wise words on funding?
Yes, heating systems linked up to reordering funding larger, very often where we see the best systems going in, because it's part and parcel of a larger lottery, possibly heritage lottery application, which is why I did emphasise in the talk about when you're making changes, think about your heating, because you can very often piggyback on a bigger funding application at that point.
And there is word that there's going to be a new government clean heat grant from next year, but it hasn't been officially announced yet, has it?
No, they've pulled the domestic one because of lack of installers and in the system. We're not sure. Just keep trawling basically, and at the moment we haven't got very much really, and let's hope that a clean heat system will benefit us. It's difficult right now.
The next question says, we're oil-fired blown air. Can this ever be efficient? It has a question mark and an exclamation mark, which makes me think they probably know the answer to their question. Can it? And if you walked into a church and saw an oil-fired blown air system? Well,
we've got one in one of our grade ones because that was the only option. It was the only option. Efficiency, it's not inefficient per se, in that in terms of energy conversion, it's not necessarily inefficient, because with modern plant, your burner basically goes to a very efficient heat transfer to the air. So you're cutting out the water. So at source, it's not necessarily that inefficient. It's not, obviously from a carbon perspective, it's not great. I talk a bit more about warm air systems next time. Depends how it's delivered and whether you can get the heat to the people. Basically, warm air systems work by pressurizing slightly the space it's in. So it can be improved in efficiency by cutting drafts down radically. The less draft you've got, the less path you've got for that air to get out, the better, because it recirculates. Most of them recirculate. So that, as such, it's higher carbon than we would like. Clearly, you know, but as an interim, you can improve the efficiency by cutting out leakage. If it's an older system, clearly it probably is inefficient. And if it shouldn't be, I wouldn't have thought with oil, it's probably got a flue off it. But if it hasn't got a flue, then obviously it's more common with gas that you put the products of combustion into the space, which is a definite replacement. It's one of those. It's one of those. If that church was in my diocese and they rang me up, I said, I'll come and have a look at it. But we have got oil-fired warm air systems that aren't necessarily as bad as you might think.
The next highest question then says, in our church we have no gas, so can only have some form of electric heating, heat pumps or hydrogen. I think we should probably add on to that list biomass as well, if we're thinking of all the options. And then they go on to ask about electric radiant panels, possibly, but they would need to be ceiling mounted, and they're not sure. So instead of, you probably can't answer that specific because you haven't been to that church, but in terms of a church that doesn't have gas.
Yeah, it depends on size of church and electricity supply. So these are the two things. So the very quick case study I did, which didn't have, which actually did have gas, but electric, it was too big with the limited electrical supply to go for an electric heating system. So it depends on the size of church. There's a huge amount of medium to small churches that are heated with electricity very effectively. Pew heaters, cushion heaters, radiant heaters, night storage heaters to extend the capacity a bit, blow heaters. I mean, electricity is really, really flexible, and you can make it zero carbon now if you want to. Obviously, it costs money to run compared to gas, but if it's small usage, then that is less of a consideration. So
and it's more localized to where people are sitting, you use less energy than trying to heat up the whole place.
Absolutely. And then of course, when we're talking heat pumps as well, I don't want to go into that too much because we'll tackle that in spades on the next one. but you've got some good choices with heat pumps, particularly small churches, air-to-air heat pumps and air-to-water heat pumps as well, ground source and everything else. So no gas is definitely not the thing it used to be, but three-phase electricity is starting to become important. So look to see if you've got 3 fuses, 3 wires, 3 fuses.
And that's a good point to put in a blatant plug to your next webinar as well, which is when a lot more of these choices have gone into, aren't they?
Yeah. Another one of my questions. First, the first little set of questions: have you got 3-phase electricity? Because your choices will always be limited with single phase.
If a church doesn't have 3-phase, if they've got single phase at the moment, I have no idea the order of magnitude of how much it costs to have your electricity upgraded, and then you've got far more options to choose from.
Depends on the infrastructure. It's as long as a piece of string. So city centre church can get 3-phase pretty readily for not very much. If you're at the tail end of a line of a transformer, and it would give rise to a transformer upgrade, unaffordable. It's
like nearly everything, it's on a case-by-case basis.
Very much so, yes. Yeah, absolutely.
The next question is off on a slightly different direction, which is about destratification fans. Is that something you have an opinion about as a heating advisor?
I get asked this a lot. Frankly, not convinced. And I had a mail from another one of my heating advisor counterparts to agree with that. I think that they sound intuitively like they should work, but the reality is that they probably will push the air down a couple of meters, but probably not to where people are. So the interesting, I'll mention, Colin's probably not on the line because he's already listened to this once, but he said that he'd done a research project about 30 years ago on destratification fans in churches, and found that the temperatures in the roof space weren't anything like as high as he expected them to be. And I suspect this is because as warm air rises, it hits a cooler surface and then drops anyway, so that you get a natural circulation of air anyway. That's destratification. If you've got a warm air system, that might be the exception to the rule. But in general, I did a project many years ago, wasn't a church, but again, we put destrat fans in. It just didn't seem to make any difference. So I'll be honest, I don't generally recommend them. But that's not to say, as I said last time, if somebody's got a case study where they put them in and they were much warmer as a result, I'd really like to hear from them. I really would.
Yes. How are we doing? Another couple of minutes. So the one at the top now is about pew back electric panel heaters. We've experimented with moving a panel and touching it under the pew. So instead of on the back of the pew, under the pew. And that seems to improve heat transfer. Does anyone else have any experience of this? My answer to that is very short, which is no, I don't.
The only thing I'd worry about with that is that some panel heaters are designed to be mounted vertically because of the air circulation, and the element could overheat. As long as it's within the manufacturer's recommendations, yes. But I would worry on some heaters because they're designed to take air in at the bottom and push it out at the top.
Yes, I would agree with that slight worry. If we had movable pews in a high-ceilinged Victorian church, how could we heat the pews?
Oh, this is a difficult one. We've got one of those, pews on casters. Yeah. Me and our electrical advisor, Ian, debated long and hard on this one because we worried about flying leads and moving. We didn't, I have to say, probably didn't come to a satisfactory solution on that one, because you've got to think how you would wire them and what you would do with leads. I mean, if the pews were moved once in a blue moon, which is I think what we ultimately concluded they would be, then you would, I suppose, plug them in, disconnect them, and be done in a responsible way. But if it was a regular occurrence, again, there was a bit of a safety worry on that one.
I've seen it done once. I've been to a church where in the chancel they had pew heaters on the choir pews, and those were movable. So the last pew in the line plugged into the wall, and then each next one plugged to the one next to it. So they had, so I have seen it happen once. You could do it, but they didn't regularly move their pews. It was kind of for the occasional.
That's the key. Not regular, yes, and the pews should lock into position when they are in situ, so there would have to be a locking mechanism, so you couldn't inadvertently move it and pull the lead out.
Now we're on 5 o'clock. I do just want though to take, there's a safety question which I'd quite like to take because it seems an important one, and apologies to the other 2 people whose questions we aren't going to get to today. Surely there should be an annual inspection by an engineer who would check the flue and the leakage, etc. Would that be true? With a church boiler would just be like your domestic one, you should have someone out once a year?
Always, but they don't always check the system. They would check the flue, the gas supply, the gas pressure, the ventilation and so on, but not necessarily the rest of the system. But yes, I mean, certainly in terms of gas, absolutely should be on every church's to-do list.
Very good. That's 5 o'clock, so it's time for us to wrap up. Thank you so much, Susan. There's such practical advice that you give. I do recommend to everyone to come to the part 2 of this series and look at if you're going to replace, how do you choose the right heating system, which is a really useful session. You don't necessarily get the answer for your particular circumstances, but you get all the right questions to ask yourself and what the menu of options is that's open to you. When we finish, I'll send everybody the slides and the links from the chat and a link through to our feedback survey, and look forward to seeing you at future webinars. Thank you very much, Susan.
Thank you. Thank you all for listening.